In this lesson, we will explore a semantic segmentation problem in Jupyter Notebooks. We are going to base our segmentation model on Microsoft ResNet and extend it by adding upsampling layers for dense pixel-wise prediction. Let's take a look at the lab. In this lab, we will use the Microsoft Cognitive Toolkit and extend our ResNet model from the previous lab. We'll add fully convolutional layers with a view to using our new network architecture to perform semantic segmentation. Although we have added layers to ResNet to create a new model, we will train this model from scratch. In the next lab, we will introduce and use the concept of transfer learning, where pre-existing learned knowledge is used to inform our approach and improve our results. As usual, we'll begin by upgrading to version 2.4 of the Microsoft Cognitive Toolkit if needed, and then we'll load it. Again, we'll unzip our dataset to the fast data area on Azure Notebooks. This might take a minute or two. We'll create two helper functions for training. One to slice up our data into mini batches, and the other for measuring the average error across our mini batches. You will need to write some code here to get the notebooks to run. See the end of the notebook if you get stuck. Next, we'll augment our model by adding fully convolutional layers. The diagram here shows how our model will change. We've removed the average pooling and fully connected layers from the end, and instead have added in some reshaping, followed by a final convolutional output. We'll also take the output from residual blocks along the way, and use transposed convolutions, also called deconvolutions, to convert these back to prediction masks, which we feed in at different points in our reshaping. Transposed convolution allows us to go in the opposite direction to normal convolution. In this case, we're taking smaller dimensional spaces and mapping them to larger ones. We'll also see the use of our dice coefficient function here, which is used to tell us how well we are doing, what the current value of our loss function is. Again, this model will be trained using mini batches. Without a GPU, this could take a while, between 30 and 50 minutes. So please be patient if you are going to try training in Azure Notebooks. If you are not interested in training, again, you can set make model to false, and the lab will use pre-trained models for you. If we have trained, the learning curves for our training and our testing will be plotted. Depending on whether you've run in Azure Notebooks or perhaps locally with a GPU, these curves will look differently. On Azure Notebooks, they're going to look less interesting, as we have deliberately limited training to a single epoch. So you'll get 2 point values like this, one for training and one for test for that epoch. On a local system with a GPU, you'll see a proper set of curves. These should have converged to a reasonable error rate. Ideally, we want the curves for the test and training sets to be as close together as possible. Normally, we'll see the curve for the training set is slightly more accurate than the test set. Remember, we don't want to see the training error continue to decrease while the test error starts to rise and continues to rise, as this suggests we are overfitting our training data. Finally, we have some boilerplate code to visualize our results and see how well we did. If you trained in Azure Notebooks, obviously, your results won't be terrific, as you haven't performed very much training, just a single epoch. We suggest in that case that you rerun the lab without training, setting make model to false, and you'll see by comparison how much performance improves, even with this simple model, if we were to train for longer. Again, remember that sometimes Python processes can get orphaned. This means they are left behind from a previous run, consuming resources. As our Azure Notebooks are limited in memory, if you see your Azure Notebook CNN labs failing with memory errors, it is likely you have one or more of these orphaned processes running. If you are getting memory errors in these notebooks, especially during training, we suggest you select Shutdown to kill your Azure Notebook session and go again from the top.